Hey folks. All right, we're gonna continue on in chapter 9 so that you guys can do the chapter 9 exercise 8. And I want to focus on the specific parts that you'll need for this exercise. If you have any questions, go ahead and post them in the chat. Wait a second. Am I in the right? .416. Oh, here I am. Okay. But why is it different? Oh, exercise 8. There we go. Okay. So, in C#, we have seen quite a bit. In the last class, hopefully you saw loops. Those are going to be useful for this exercise. You're going to need to create your own class, which is what we've been looking at in chapter 9. So make sure if you haven't seen that first video, it would have been the last video, you take a look at that. And then we're going to go over the rest of the stuff that you need today, and then I'll just continue through chapter 9. So let's make a list here. We need to show, and I think I'll just make a new demo for this. So we'll do chapter 9 part 1 demo. Alright. And we will do a new one for part 2. I'm just going to copy the exercise here and throw it in a comment so we don't have to keep switching back and forth. All right. All right, so important stuff in here. So we're going to need to create a class, and then using user input, create instances of the class, so create objects. And then we need a Compareto method using the iComparable interface to tell our program how to sort our objects. All right. Okay. So, to keep it interesting for me, we're gonna create a board game class, and then we will add a few different ways to sort it, and then we will look at how to create a loop that takes in user input and creates objects, and then we'll go from there. We'll see if I think that's enough to get you through here. Okay. So I should have been writing these down as I went. So let's go. Create a new class. Make it sortable. And loop to accept user input to create new objects. And we're just going to store the objects in a list. All right. So first, creating a new class. So we want to create a new file. And in most modern text editors or IDEs, when you're dealing with C# and you create a new class, it gives you kind of a boilerplate to start with. It doesn't do that in Replit, so I just copy the existing code. Oh, it just switched. There we go. You'd think I'd know if board game was 1 or 2 words, wouldn't you? Okay. It's 2 words. So we capitalize. I want to make sure we're doing this right. Sure we're using the right languages, naming conventions, and all right. So we'll start with this. Not sure why it's not following the color coding here. Let me open up the other demo. Or let's actually just try refreshing it first. There we go. The tried and true troubleshooting method for computers. Restart it. Restart the computer, restart the program. That clears out any problems in the memory, and if it still doesn't work after that, then you have to do a lot more work, but usually this will fix minor things. Okay, so we don't need a main, and we need to name our class. So I'll call it board game. And now we'll list our properties. So For a board game, probably want to keep track of the name as a string, right? And we can just set get and set getters and setters for that property. And just to save time, I am going to open that other demo because we had already done this, so that way I don't have to double check the parts we need. All right. Okay. So remember in the last one, we went through and created a property manually by creating the backing field and then manually putting in the get and set methods here and what they do. And then we looked at the easy way. So when you create a field, you can either do it this way or you can do it this way. We're going to use the easy way for now. You don't really need the other way until you need to manipulate the get or the set method. So what else is there about a board game? Well, let's go ahead and give it a number of players. So we'll call it num players. I'll just put those on the end later. What else? Let's give it a rating. Oh, you don't? Yeah. Is there ever a reason you would add the backing field? If you want to have a private field that only the class can see, then you just wouldn't make it a property, right? Okay. Okay. What's the best decimal data type for C#? Is it just double?
I think decimal is a data type.
Is it? Okay. Let's give it a rating. And I think that should be enough for what we want to do. So remember the steps of creating a class, create your properties. What's next? Think about it from last time. What part is next in creating a class? We need to add constructor methods, right? Easy, they just have the same name as the class, but they are a method, so we have to provide a way to put a place to put the parameters. In this case, we're gonna create a constructor for the default class here first, and then we can just set the values here. And we can take a look here. Bandwidth. I don't think we had that in default on this one. And so we'll just set each of these properties to some default. oops, that's an int. And then rating, we'll set to 6.8 as a default. Well, let's go 6.1. That would be a rating that a game would get if it's worth trying once, at least. All right, so we have the default constructor that'll just throw in some values if we need to test things. But we're going to have another constructor method that'll take in the values as parameters. So we need a string name. And when you're creating parameters, you get to choose the identifier. So I know I'm going to need a string value for name. To make it simple, I'm just going to call the variable name lowercase, and I'll just follow that same pattern. No reason to complicate it. At this point, you're just following steps. And these will be the same steps that you'll follow whenever you're creating a class. Sometimes you have to add extra things, but here's the bare minimum. Okay, now that we're taking these values in from the constructor, we don't need default values. We just use the values that are passed in. So name equals name. Notice here I have the name of the property. Here, this is the name of the parameter. So this one is referencing this, or I'm sorry, this that we created on line 6. This one is referencing the parameter here. Okay, so what will this line 17 do? It'll take in the value passed in to the constructor, and it will assign it to the property of the class. So we just have to follow that through. All right. Now we make sure I didn't break anything. Let's just use double for now, and I'll have to research how to use that. Oops. All right. So no syntax errors. And remember, every time you add something, you probably want to test it. That way you can fix the error and be on top of your errors instead of doing it all, figuring out half of it's wrong, and you have to undo it and then rewrite it all. Just got back from the dentist and my teeth really hurt, so if I'm acting weird, more weird than usual, that's probably why. Alright, so now we can use this class, and I'll just show you that real quick. We may have to create a namespace first, but let's see what happens. So, I can just use using, right? Or does it also have to be in the namespace? If it's in a separate file, okay. And it's very important, I did miss a part here. We want to make this public class, and we want to make these constructors public, or we won't be able to use them. And that's kind of an important part. Okay. Now we should be able to create that. We'll want to do using board game. Actually, no. We want it, whoops. Sure you hit the right buttons. Okay. Put our namespace down here. We'll do B, G, board, game, sorter. And then you just include everything in the class in the namespace, like so. Fix your indents. Okay, do the same thing here. And again, actually, probably want to make this capital. There we go. That way it knows. There we go. And we use these naming conventions to make it easier to keep track of what we're doing. So, for example, in the board game class, at a glance down here, I can tell that this is a property because it has a cat, starts with a cap. I can tell this is a local variable to this method. So this will be gone once the constructor is gone. This will stay in the object. All right, so finally we're set up to create our class or create our object. Yep.
You can use a using statement if you use a different namespace in the file.
Okay.
And use that namespace.
Thank you. So, remember, when you're creating an object, what is the type of that object? Because in C# we have to type our variables. If we're going to create a variable to hold our object that we create. And remember, technically it's holding a reference to the object when we do this. What will the type be if we're using a class to create an object? It's just the name of the class. That's the type. Now we can give it a variable name. All right. Into that variable, we're going to create a reference to a new instance of a board game using the constructor. We'll give it a name of, let's see. I played this game yesterday. Let's use that. All right. It's up to 4 players. Here's the name, and we can check the rating. .7. It's a very respectable score. Now let's see if everything explodes or if it works. And just since we're looking at this right now, I'll just show you a picture of what the game looks like. So this is a game where you are a traveler going across Japan, and you're trying to have the best time. So you're collecting souvenirs, you're trying new foods, you are seeing panoramic vistas, visiting hot springs, all that kind of stuff. And whoever has the best trip wins. Okay. So that's our first game we're adding here. See if it explodes. Probably forgot a semicolon somewhere, and I know that because here we have unexpected symbol end of file. So something didn't get closed is what that means. Line 20. Alright, so I'm not closing the namespace because I probably distracted myself midway through adding that. Alright, and we can create an output so we can see this. Alright, so we will do console.writeLine, and I have this one right here, so we'll use that. And we'll go ahead and use string interpolation again. I think we used that in this class. Actually, no, I think I used it in the Web Scripting 2 class. So we'll look at that here. Maybe I did use it in here, I don't remember. We can check. Yeah, that's this right here. Okay, so how do you use that? Well, you can just type out what you want to say. Don't worry about concatenating anything. So we'll do name. We'll do this to reference the first index. Go to a new line. We'll put players, max players. Put in that second value, and then a new line we'll put rating. Alright, so we're telling it we're going to have 3 values. First one will be game1.name. We can just access it right out of the property. The second one here is going to be players, so we can do game1.players. And we want to do rating.
That's not string interpolation.
Oh, what is this one?
That's just an overloaded method of writeLine.
Oh, okay. Which one is string interpolation?
$sign in front of the quotes.
And then,
And then you just insert variables in curly braces.
okay. So there's another way you can do this. That's even simpler. Put a $sign here. And then instead of listing the variables down there, you can just put them right in here. Thank you for the heads up.
It's like a minute delay.
Yeah. That way people can't see what cards I'm playing in Hearthstone. No. I don't know. It's probably because of reasons. There we go. See if I messed everything up. Yep. Alright. Forgot my semicolon. There we go. Wow, really made it mad here.
Once it catches up, I'll tell you what's wrong.
Thank you. Oh, forgot to make the properties public. That's kind of important, huh? There's so much pre-set up in C#, but it's for a good reason. And it's hard to appreciate when you may consider it just extra work. If you've taken a, JavaScript or Python class where, in Python you just put a variable name. You don't even have to tell it that you're creating a variable. But here, we do have to provide a type. We have to provide a privacy level, the access modifier. And why don't you guys think about what the benefits of doing this is versus the benefits of doing the way Python does it, or a language that's not typed. Hopefully you can hopefully you can come to the conclusion. If I remember, or you want to know later in the video, just say something in the chat, mention it. I think I've mentioned it in previous videos though. Alright, did I fix it? No. Okay. Players. What do they call it? Num players. Alright. I should have called it players. I'm just going to change it now, because I'm going to keep making that same mistake. Changing things later is much harder, because you have to remember to change it everywhere. Cutting this error off. TY is not a good error message. The name, num players. Oh, I forgot to change that in here. Nope, 12. I changed one constructor, but I forgot the other one. All right, let's see. Can we get something to work? Yes. Okay. And I'll go ahead and put a line return before what it's going to print out. And so you can see it's outputting the same thing for both. So, I recommend using this way. It's just cleaner. You can see exactly the variables where they are in the string. You don't have to include a million extra double quotes and plus signs, and you don't have to list the variables afterwards. Just the most concise way to do it, I believe. So here I'll label that. And I'm going to grab some Advil because I feel like my teeth are going to fall out. Say what?
You share the REPL like before? Or no?
No, I can send it to you if you need. So, I think we got our first thing done, creating the class. Now the next step, making it sortable. And to do that, we need to use this interface iComparable, which allows objects, or it provides a way for objects to be sorted in a list, or basically in any sort of iterative structure that's iterable. Right? Which means a list or an array or something that contains multiple objects or multiple values. Okay. And I think I actually have some code we can look at for this, and we'll see if there's anything in the PowerPoint. That is not it. There we go. Let's see if this is it. Yeah. All right. Oh, we added the class up here. So, to use an interface with a class, you use this colon and then the name of the interface after the name of the class. All right, so what is an interface? Let's see if it goes over that in here before we talk about it. So you can look through here. It's kind of got some information about what we've done so far. Created an object. We haven't given it a method yet. Blah, blah, blah. All right, so one thing that's important, since they're bringing it up here, and I don't know if they're going to mention it again, is about access modifiers. And first I'll give you my impression of how I understand why they exist, and then my colleague may have a better idea. So I like to use an example of working at a bank, all right, and taking, customers come in, they deposit money, they withdraw money, and they do all kinds of things. And you can think of those things as methods, and the things that they do are methods, and the things that they change, like their account balance, those are properties. All right, so let's say we had a class representing a bank. All right, and let's say this is an all-cash bank. Just to simplify well, this is a bank in the 1800s. All right, let's say a customer comes in and he or she wants to deposit $10, which back then was $1 million. The teller would probably need to do some extra steps to accept such a large amount of money, and maybe it would get put in the vault immediately because we don't want bank robbers to get the money. All right, so when the person goes in to deposit the money, it's ultimately going to end up in the vault. All right, the customer does not put the money in the vault. they give it to a teller, and that teller makes a record, and then eventually it gets put in the vault. All right. When you're creating classes and methods for classes, what you're doing is you are creating a blueprint, a set of rules for how to use that class. Okay? If you include a bank vault in your class, something that is similar to the idea of a bank vault, you don't want just anyone to access that. You want them to access it in a very specific way through the tellers. And so you might think of that as the tellers as methods. All right, so let me make sure I'm including every part in this example, making it coherent. Using public and private is a way you can control how people use your class. It adds guidance, and it adds limitations so that people do not access things in a way that you didn't expect. All right, so if there are fields in your class that you don't want people outside that class to affect, you want to make those private. For example, in the board game class, let's see if we can think of one that we might want to make private. Might be a difficult task. Feel free to chime in if you can think of anything. So it would have to be some value that would be used by the class, but that you wouldn't want people, or when I say people, I mean you wouldn't want methods outside of this class to be able to access that directly. So let's say this is more of a, let's see, you know what? Let's not waste your time with me trying to come up with something. Let's go. Examples of private fields in C#. Not private. Yeah, private fields. Actually, I want an example of values kept private in C#. Yeah, if you think of something, go ahead and put it in there. Here we go. Here's a calendar example. That might help me think of something for hours. Okay. So here's an example. In this calendar, they have a private field of date time, that data type called date. And I'm sure we can check, but I'm sure the date time value is potentially an integer that represents the amount of time that has passed since whatever epoch C# uses. A lot of them use January 1st, 1970. Anyway, you don't want people changing that outside the class, and you don't want people pulling that outside of the class because whatever reason, maybe they listed it here. I thought it said something about a calendar. Here we go. for example, a class that represents a calendar date might have 3 fields, one for month, day, year. Variables that are not used outside the scope of a single method should be declared as local variables. All right. And so, if you don't want people to access this outside the class directly, you can set it to private. And so to be able to use that, you can only change it within the methods of this class. So you can control how people interact with that. So how are they doing that here? When someone inserts or tries to set the date property, wait, this isn't, trying to find an example that uses, did you put something in there? Oops. Oh, okay. Well, you know what, as soon as class is over, I'll think of it, but I can just show you how it's used. Oh, I'm sorry. What am I doing? I'm doing access modifiers. Okay, anyway, so well, let's see what the PowerPoint says.
There's very rarely a case where you're going to need private fields.
I know. Alright, access modifiers. Here we go. So you want to use fields or declare fields as private when you want to keep values hidden from other classes. And that allows you to control, basically it's you deciding what people can do with the data inside your object. By using public and private, you control how they access and how they manipulate the data. So if we just made the field public, they could put any value in there. But if we want to, be able to validate or control what goes into that field, we can set it to private and then have a method change it. All right. Because we don't want the customers, we don't trust the customers to write their deposits in our ledger, and we don't trust them to put the money in the vault themselves. So they have to go through the teller. And that way they don't take extra money out of the vault, and that way they don't write down that they have paid all their debts and have $1 million. Or, again, back in the 1800s, $10. All right. But now I'm curious. All right. So, somewhere around $200. $10 was $200 back then. Not quite. Not quite $1 million. But it's hard to relate to 1800s. So who knows? Okay. Anyway, we've got our thing here. Where were we? We were adding the interface. Okay, and then somehow I got on this modifier. Oh yeah, because I was looking for if they talk about interfaces in here. Alright, we looked at constructors already. Oh yes. the initializers. So we can shortcut some of this. Are you seeing what I'm looking at right now? Is this right here where they're using this 9990, is that only possible because they have this method? Is it just using this method to fill in that basic one? I guess I could just try it. Alright, so right now our constructors look like this, but we could make them more concise by doing this here, which involves a colon, and we can say this, which means I think in this context would be the instance of the object. Or wait, this might actually just be referring to the actual constructor method, right? And so we can go default to 6.1 for our default values here. See if it works. Okay. Let's also create an instance of the default one so we can just see how that looks. So here we're creating an instance of an object, or of a class called an object, and we want to, instead of passing in the values, we want to just put in the default constructor, and then we can just change here, here, and here to 2. And if you want to do this, if you want to use that technique, all you have to do is click to select something, a spot in the code, hold Control, and just click somewhere else. You can add more blinky lines. Didn't look those up, and then you can edit all 3 at once. Alright, so now let's see what prints out when we print these. So we can see here's the game 1, here's game 2. Right. And it saves us some lines in our class. Alright. And we still haven't made it to interfaces yet. Okay. Let's not worry about read-only for now. Here they have, they're showing something called object initializers, which is, looks like it's a way you can just manually set the properties instead of using the constructor. Have you ever done it that way? well, it's behind, but it says new employee as the mentioning the constructor. You can see it? Okay. Do you ever use that? Overload the... It should be... What's up? Alright, while he's doing that, I'll go ahead and keep looking.
Does it look like that? Is that what it's trying to look?
Yes.
Yeah, that's pretty much how I always initialize objects.
Okay. And here, do you have to specifically use the property names?
Yeah.
Okay. I mean, that's fine. All right, and so now we can print that out too.
If you'd given better property names, it would have been intuitive.
I didn't get the identifier style sheet rules. All right, so here's another way you can declare objects. And my web developer friend says this is how he always does it, and it's good because it shows you if you're working with a lot of classes, and tell me if this is true or not. If you're working with a lot of different classes and you initialize your objects this way, you can see what the property names are. And you can also, so he's formatted in a very readable way, and then in PowerPoint they show the way they're doing it is putting it all on the same line, which makes it really hard to read.
Also makes it hard to debug.
Good point. If you put it on multiple lines, it'll give you a more accurate, a quicker to find error. If you get an error. Okay. All right, declaring an array. Let's see if they only use arrays. If they're only using arrays this chapter, we'll use an array. Okay, so it doesn't talk about interfaces in here, so for now they're a magical thing that allow us to do magical stuff. And then later we'll talk about, when the book goes over it, we'll talk about when maybe if we make our own, we'll see if it goes in depth. Because you don't really make, you don't really make interfaces all that often, you just use them mostly, right? Unless you're making something.
You can make them. You'll make a lot of them if you're doing .NET.
Right.
Dependency injection.
Okay. So let's move on to the next part, which is making it sortable. So we're going to do that by using this comparable interface. And it's nice, it's pretty easy to tell what is an interface I don't know if maybe looking, this is the only one you've probably seen, but maybe you can identify what about this kind of gives it away that it's a interface. So I'll let you think about that. Do I need this anymore? I don't need this as much as I need this. All right, so I'll give you a little rundown. What this iComparable interface lets us do is it contains method signatures, which allows classes to use similar methods. All right, so the method that we care about from the interface is this. Actually, where did I put it? Oh, right here. Staring right at it. Keeps wanting to make that bigger. There we go. Okay, I did not indent this code. It was making it very hard to see. All right, so we'll go ahead and copy this as a start. We're going to put this in our board game. Now, I'd be really surprised that it expects you to use this without saying anything about it. So let's see, there's got to be something in this chapter about it. Let's take a look here. Comparable. I mean, they should have at least given you an example to go off of. Here we go, 397. All right. All right. So, okay, they do talk about interfaces, and you might have removed those from this PowerPoint. Let's see. Which is weird because you use them in the assignment. Oh, here it is. I guess I just skipped over it. Okay. So we do get to talk about it. So an interface, we'll go off what it says here and then we'll try to break it down. A collection of empty abstract methods. Keep that term abstract in your back pocket for now. That is important in object-oriented programming. When you add a method to a class, the objects created from that class can use that method. No other class can use that method unless you create an interface which contains the empty abstract methods and you an interface contains the empty methods, and if okay, so one class or one object cannot use another object's methods. They can only be invoked from that class or object, depending on whether it's static. What? Oh, it might help. Okay. But the interface only includes these empty methods, so method signatures. And if you include that interface in your class, remember when we added Oops, that's not the right one. We added this right here to our class. What that means is we are promising that this class, board game, will provide a definition for the methods in the interface. That's right, right?
Yeah.
And you have to provide all of the methods from the interface?
Yeah.
Okay.
Try running it.
Okay.
See what it says.
Board game sorter dot. Okay, so the board game class does not implement interface member compare to. Because we added this interface, we're promising that we will add the methods from this interface, which include this compare to method, which takes in an object, and we'll get to explaining how it works here in a second. All right, did you add an I like dogs method? Okay, so here is declaring an interface, and I think it will be a while before we do this, but just so you can see and have some background information, here's the interface called I like dogs, and all it should contain is a method signature. All right, so we have the type, the name of the method, and the parameter, or parameters, or you might not have any parameters. All right, and then so here another class was added in the same file here, so it's separate from our board game class. And here, since we have the colon and the name of the interface, we're saying our sum class will have to implement the methods listed in this I like dogs interface, and it contains one method called dogs. All right, and so that means we have to include a method inside of this class. This is all like rushing back to me now, with the same method name. So we're saying, okay, if anyone uses the I like dogs interface, they have to include a dogs method. All right, and so here the dogs method prints out whatever you pass in as a string into the method. All right. All right. All right, so now we need to add that compare to method to the board game class. All right, and oh yeah. All right, so I have that example here to save some time. Here's the method signature of compare to. Now, what did we use interfaces for the most? Like, why would you need an interface? It's to have two different types of objects perform the same functionality, right? So they can both do the same type of method. So if you iterate through a list of different objects, they'll be able to run the same method.
That's what you're compare to allows it to sort.
Right. But we have the compare, but we're saying we're doing the compare to from the iComparable class. Why didn't we just create a method that sorts it ourselves? What's the benefit of doing it this way?
So that you can pass it into libraries as a sortable object.
Okay. So we need to add that method. And so the order of things in a class, you should generally follow this. You want to put your private fields, your properties, then your constructor methods. I can label these sections for you to keep you from having to rewatch the video every time. Let's go here. So we have the constructor methods. And then below those we can put our other methods. Now, do you usually sort your methods at all, or do you just kind of throw them in there? Do you put the specific?
I would put the constructor at the top.
And then, like interface methods, do you put at the bottom, or do you really care?
I don't really care.
Okay. It's good to have a web developer here to ask specific questions about how you would be doing it in the real world. So we need to add that compare to method, and we need to give it a definition. All right, so what the way this method is meant to be used is it needs to provide, it has a return type of int, so it needs to provide a value that allows us to compare two objects, and the value that we receive will tell us whether they are equal based on whatever we're testing, or if one is greater than the other. And then it returns that int, and then whatever iterable structure we're using, an array or a list, can run through and compare them to sort them in the right order. All right, and so the cool thing here is, well, let's say if they were ints, we know they're going to be sorted by numerical value. If they're strings, maybe they'll be sorted alphabetically. But how do we sort board games? Maybe we could sort them alphabetically by name. Maybe we want them sorted by rating or by number of players. You can do that too. You get to specify how you want them sorted. Yeah. Maybe you want them sorted. Could you do 2 levels of sort with this?
You can do whatever you want. The function just has to return 1, -1, or 0.
Okay. So yeah, so within the same, so if we wanted to sort by number of players and then within that sort by rating, we could do that too. And so let's say you wanted a list, let's say you're going to have friends over and you want a list of board games that can play 4, and maybe you want to have your highest rate, you want the order descending by rating, so you can see the best ones first, and that'll help you pick. All right, could do that. So let's just start by sorting by name in here. Okay, so I'm gonna copy the code here so I don't forget any part. So let's run through this. First step, we're creating a local variable to store the int that we're going to be returning. and we're going to be returning either 1, 0, or -1. 0 would mean the values are the same. 1 or -1 would tell it to put it before or after the object being compared. All right, so they're also creating a temporary object to hold, or they're creating a variable to hold the reference to the object being passed in here. It's a mouthful, right? Don't forget you can turn the speed up or down on YouTube. So if you're following along and you feel like I'm talking too slow, turn that up. If you get lost, turn it down, and that way you can catch all the words and try to understand what's going on. Okay. So we're not working with conferences, or in this example, you'll be doing that in the homework. We want to create for a board game.
Instead of having to cast it, I think you can set the type of board game like that at the top.
Oh, okay.
And then pass in a board game here.
All right. Shortcuts. I'll make sure you guys have access to this code too. So you can try to reverse engineer it into what you need for the exercise.
I don't think that's necessary.
What was it? Oh, okay. Would you have to use... Okay, yeah, let's try it. That's implied, probably, right?
I mean, look at the example below. I don't say I like dogs.
Mm-hmm. All right. So we don't need to cast it then. All right, now we can create a test. And so we want to create a structure that can only have one of 3 outcomes. So we're going to need an else if statement. Yeah, I can do that. All right, so this was a property from the conference class. So we want to do, and you don't need to put this even, do you? You didn't do that, did you?
I didn't set any properties.
Oh, okay.
You don't have to unless there are name conflicts.
Right. So be careful about using the same name for things. Otherwise you might get confused about what it thinks you're saying. All right, so we have the parameter of bg being passed in here. So we can just use bg. Oh, we want to do this one will be the bg. As long as we do it keep it in the right order in both. All right, so what were we going to do? We're going to sort them by name. No, we're going to sort them by rating. Let's do that first. So we just use the property. I think I'll just put this in here so it's easier for people maybe to identify where it's coming from. And we'll have to talk about implicit and explicit when using methods of an object. All right, so if the rating of the object that you're using to compare to another object is great, has a rating greater than the object being compared to. Let me word that. If the first object has a higher rating than the second object, we want to make sure that the first object returns a positive 1. All right, and if we have the opposite, we want to make sure it returns a negative 1. So here we're comparing if it's greater than rating, and here we are comparing if it's less than. Okay. Do we need to compare the two to see if they're equal? Well, let's see. The domain of values that we're considering is every number oh, I'm thinking of something else. Never mind. If it's not 1, if it's not greater and it's not less than, the only other option is that they're equal. So we only need else for that. We don't have to explicitly tell it to check that they're the same. If they're not, this is saying if they're not different, they're the same. Okay.
Can you explain single line ifs?
Yeah. All right. And then we return the value, and now this class can be sorted inside of a list or array or whatever collection type data structure you want to use. Now those classes, they also implement iComparable, or iIterable or something like that, and that calls the Compareto, I believe. So let's see if we can make sure this isn't broken. Or name get. Say what? Okay. BoardGame.name.get is inaccessible due to its protection level. You don't have to explicitly put public in front of the get and set in the quick property.
No, but you left temp.
Oh. I see. Whoops. Not in there. Alright. Oh, right. Make it public. There we go. So it compiles, but we don't know if it works yet. So we need to move on to the next step. So we have the code done for the sorting, but we can't test it yet because we don't have a structure to hold that. So let's move on, and we'll create a loop that will ask for user input and fill in I guess we'll use an array, and we need to include system.collections dot generic, or is it generic dot collections? We'll see. And I don't know if you actually need to do this for an array. We'll see. I'll just comment that out for now. Alright, so instead of declaring 3 of these, we will, well, I guess I shouldn't comment those out because they're being used down here. So I'll have to comment all of this out here. All right. And now let's work on that loop.
I was showing this method at the bottom
Mm-hmm.
takes any object that
Oh, that one.
does that, and this is why.
Okay.
I mean, this is why we use interfaces.
Okay. Some class.
So this one,
Yeah, put some comments in there. Thank you. Alright. I'll put the loop up here so that way it's before this stuff. Let's see. So in the conferences, it wants you to create 5. So you would create a loop that runs through 5 times. If you're going to do an explicit number like that, a for loop is fine. It's more concise to use a for loop if you know exactly how many times you're going to go through. And so to do that, we're going to create this. Let's see if I can remember the syntax in C#. So for int x equal or assign 0. So we're declaring our count there, and then we want to tell it when to stop using a condition that's going to return true or false. So when it gets to greater than 4, we want to stop. So that'll be what numbers are included if you start at 0 and you stop at 4. How many numbers is that going to be? That's what you need to think about when you're writing your condition. If you're doing an explicit number. So in this case it would be 0, 1, 2, 3, 4. Those would be the indexes, and that would be 5 total loops. And then you got to tell it how you want it to loop through, and you can really do some crazy stuff in here to do some really crazy patterns through things, but since we just want to go one time through, or I'm sorry, we want to increase by 1 because we want it to go 0, start with 0, end with 4, increment by 1. We can use the increment operator here.
I'll start 1.
Oh, whoops. Yeah, it's better for display. So there is, you can use increment before or increment after. So in this case, we wanted to increment. Oh no. That's hilarious. Who went there first? Alright. So this will be a loop that goes through 5 times. What do,
4 times.
will it?
Yeah. It'll go 0, 1, 2, and 3.
Oh, I used the wrong. Wait, no. What was I thinking? I was thinking this, I think. Greater than or equal to 4. Less than or equal to 4. I have not eaten today because I went to the dentist. Did I mention that? And I don't think I can eat I have to look up what I can eat because I can't eat anything. All right. My problem, not your problem. Except it is your problem because I can't think. All right. I'm way over time anyway, so if you guys need to go, that's fine. You can watch the rest later. But what do we want in this loop? Loop to accept user input. So we need to ask for the input to use for the object creation. And then we want to store them in, I guess we're using an array. All right, so we want to declare that array before we try to insert values into it. And so you can look here, let's see how they're doing it in here. Oops. All right. Fairly simple. Just need to provide the type. Oops. Where did I put it? Oh, right in here. Oops. I thought my cursor was your cursor. All right. So here we are declaring, yes, an array. So we give the type, we put these square brackets, we give it a name. So this is the identifier that tells us how to access that array, calling it board games, because we haven't used this name in this context here. And we're going to initialize it with, this is what, initializing it with 4 empty board games.
I never remember if that represents the number of elements or the max index. I guess we'll see if it gives an index out of range.
Yeah. I guess I'm thinking of a list where you can just keep adding things on, but you in C# you have to explicitly size the array. Okay. I think I remember that from Java too. Because Python and JavaScript have dynamic arrays. Does JavaScript have dynamic arrays?
Yeah.
Okay, thought so. So the first thing here is taking the user input for the first object. So I'll see if I can remember how to do that. And we want to store that in a local variable that we'll use to pass into the constructor. So I guess we can just call it lowercase name, because it's a local variable that will, I believe in a for loop, if you declare a variable in a for loop, it's only within that scope, right? Remember these things that I'm saying so we can test them. I'm pretty sure. And then, yeah, make sure you put a message, otherwise you'll be like me last time and think the program's frozen. Okay. And we will need oh, cool. So we're using the count here of x. Remember, it'll start at 0, and you can actually keep track of which number you're on by using that. So we can ask for the name of game and then provide the number of which one they're entering. We add 1 here so that it displays as 1 and not 0. And we just have to repeat this pattern for the other properties we need to take in. Thank you. All right, let's see if that works. And we could just put a console.write right after the for loop.
That's going to be 15 entries.
Hmm.
Maybe you can just test it.
Yeah. Whoops, what is that? Let's put let's lower it for testing purposes to a couple, because that's a good point. We're gonna have to enter in 15 things. So while you're here's the thing, I know some of you guys tried this assignment, the conferences assignment, before we had gone over what you needed for it, and you've probably, every time you've used a loop, you probably noticed it's annoying to enter in 100,000 different values every time you want to test it. There's nothing to say that a loop is going to do the same thing every time, so you can lower the iterations just to get some test data, and then you just have to remember at the end to go back and change it to how many ever you want.
I'm not sure what's happening there.
Hmm. Does it let you do anything? Let's see. The chat window's right in the way here. Let me clear it.
It's not affecting the inputs, but it's something to do with.
Alright. Actually, I have this string built up here that we can use. Oops, let's use the string interpolation one. So if we want to access, we'll just pull out one and see how that goes, because we're going to have to use a for each loop to print them out, which is, actually, let's just skip to that. So if you have a collection of objects, so in this case we have an array, we can just do a, what's that?
It might, but I'm not sure if for each exists on an array.
Oh, good point. We'll have to, then we can just use a for loop if that's, hopefully it's a for, we can do for each game in board games. So we put a, thank you, we put the type for the variable. Here we choose the variable name that we're going to use to pull out the objects and store in for each iteration. and then we put the name. Is it in, or am I thinking of Python again? We'll try it. But anyway, here's the array we declared. We use the name of the array, and it should go through as many times as there are objects. If not, we'll just use a for loop, and we can use the length property of the array to determine how many times to loop through. So either way, it's easy. Now I want to copy this string into there. You beat me to it. Oh, yeah. I put that other one as a trap. I think... Okay. Game... Oh, right. Use the name of the variable. So each iteration of this loop, each time it goes through the loop, it will grab out one of the objects, store it in game, and then we can use the properties of that object to output. All right. So, asking me some names. Let's go checkers to. We'll give checkers a 4.7 because I believe it's a solved game, which means if you know the solution, you can't be beat, which doesn't make it a very fun game. Kind of like tic-tac-toe. All right, we'll do chess.
Your picture's covering up
Oh,
the console.
thank you. All right. And now we want the number of players. Chess is 2. There are versions of chess with multiple players. The rating of chess, we'll give it a 9.1. All right, this is an extremely globally popular board game. And game 3, we'll do Mancala. Oh no. Oh well. Okay, Mancala, which is an African game about bringing cattle to market, represented by what looks like a wooden egg carton and marbles. It's 2-player. It's also a solved game, so we'll give it a... But the pieces are more fun, and it's more satisfying to play than checkers, so we'll give it a 5.1. And everything exploded. And I am going to change this to only go through one time, because I don't want to enter all that again every time. You see, is this just going to error out if I do it like that? Alright, I gotta finish this example so I can get some food. Oh, I guess I could just put whatever I want in here. It doesn't have to be real information. Alright, so what is the error here? Lines.
It's a null reference.
Okay, so something isn't getting a value. Not set to an instance of an object. Okay. I wonder if it's this. Let's do... Oh, let's look in the PowerPoint and see how they're declaring the array.
Oh. One of the more important things.
What's that? Oh, actually putting it in the array. So, we're skipping step, or I was skipping steps here. After you get the 3 values of the board game, you actually have to store them in the array. So, we have to create a new object, and then we assign it to the spot in the array based on our index, which starts at 0, so that's the first spot. All right. And I wonder, since the array is set to 4, which is 0 through 3.
Well, we never even accessed an index of the array, so
Okay.
it would have gotten out of range.
All right.
Is that not how you're... How do you set up your shape constructor? Oh, that's why.
Oh, right. When we're taking an input from the console, it comes in as a type of string, and this constructor requires an int and a double along with the string, so we have to convert those. By parsing the string into the right data type.
I don't know how to parse that.
Let's see. C# parse double. Parse string to double. Okay. One example here is convert dot to double. I don't know where that convert is coming from. Oh, I want to do casting, right? No, we're doing convert. What is it that we're using here? Parse. We'll just see. We'll try that. No. Yeah. If you just do double dot parse, it should work. Yeah. Maybe. So here's some values for the game, and it should print out. Or it might be the for each. Do you think the for each is going through every spot, regardless of if there's a value? Nope, it's not that. Maybe it's you can't cast as or parse. Here they're showing, no, what's this? Okay, double dot parse. Let's look at the documentation here. Things do change, and so if you're trying something in the book and it isn't working, you might have to check the official documentation to see if it's been deprecated. Let's see. Converts the string representation of a number to its double precision floating point number equivalent. It looks like you have to change the... This is crazy. You have to change... the decimal place in the string. No, you don't. Okay. The convert didn't work either.
That's not the issue. It's the int32.
Oh, okay. It's not throwing that other weird stuff from the read line, is it? In there?
Let's see.
It's probably hard for you guys to see what's on here. I'm just trying to read it to see. Okay.
Yeah, it is.
What is?
It's putting everything.
Oh, okay. Oh.
Try refresh.
Okay. It's a good idea. No idea what that was. Let's turn the sound off. Is Replit just screwing up here? Oh, is it just part of the... Yeah. Oh. No. What if we just did... Oh, you go ahead. Oh. Okay, that makes a lot of sense. We got to declare our variables outside of the for loop.
Not sure.
Because, yeah, you wouldn't want to declare the same variable over and over again, right? I guess it does disappear. Well, it disappears after it runs.
Yeah.
Here, I'm going to try this. If we just go here, let's see if it's that. Nope. It's very weird. Let's see what this is. Oh.
It might be because we're sharing. Post it in a different.
Okay. This is part of the job, trying to figure out what's how to make things work. Okay, C#, read line. If we just print out the, well, read line is adding to the console.
It's because we're sharing the REPL.
Oh, it worked outside of that?
Mm-hmm.
Oh, okay. So, here we go. There we go. Alright, so I will make a copy of this, because we're almost done. Just got to get across that finish line. Alright. The name of the game is A. It's one player. It has a 1.1. And we are outputting some stuff there, but let's do it for here. Okay, so 1.1. All right, so it printed out, and then this is, yeah, I think a for each is going to go through every value, maybe. Print the array. So if we're only entering one value, we need a smaller array. Let's see if that fixes it.
What are you talking about?
Yeah.
You don't need a for each anymore.
Really?
No, give me a second.
All right. So if we want to do more,
Did you call it name for the name?
yeah. If we want to do 5, then we have to change this back to holding 5, and oh, forgot to test the sort. So let's go back. We're gonna need multiple. We're gonna need well, I mean, we were yeah. We're gonna need multiple to test the rating or the sorting by rating. Okay, so for that, we'll see if an array has the .sort method. My teeth. Oh. Now, does this sort the object, or I mean the array, or does it return an array? Well, I guess we can just test. Okay, so that doesn't work. How did they do it in here? Wait a second. Using the sort method with an array of objects. Array.sort. Oh, and then you pass in the array, duh. It is a static method. Array.sort. So that means you call the method directly from the class of array. And you don't do this, which I don't know why I thought would work, because board game. Oh, never mind. And I did not do that right anyway. All right, let's see what happens. Board games is what it's called. All right, so we are to sort the array. We're going to call the static method from the array class. We're going to use the sort method. That is a static method of the array class. And we're passing in our array, which is an array of board game objects. Inside of the class for board game, we specified a Compareto method, which it will use to sort these objects in the array collection. Okay, so let's do 1.1, and it broke. Oh, because I only changed this 5 and I did not change the loop. And let's make it less confusing. I'll just go back to this. So you can see it starts at 0 and it goes to 5. I'm sorry. It just makes more sense if you go 0 and 5, because you're going to have 5 things. It will stop at 4, 0 through 4. Okay. So 1, 1.1, 2, 2.2, 3, 3.3. Yes, I paused because I had to think about it for a second. 4, 4.4, and 5, 5.5. Now don't crash. All right. And I was stupid. I put them in order.
You didn't display them?
No, I displayed them. I wasn't that stupid. All right. I put them in the array in order, so we can't really tell if it worked. So I'm going to have to type it again.
Oh, you typed it in the...
Yeah. 2, 2, 2.2, 4, 4, 4.4, 1, 1.1, 3, 3.3, and whoops, put this one at the end, 5, but let's give it a rating of 1. All right, and remember, we set it up so that it would sort the objects by the rating value in ascending order. Okay, so what we've created is a list of the worst to best rated board games. Not as useful as a list of best to worst. How would we change that? Well, we just have to go back and edit our Compareto method. And we just have to reverse our return values here so that they go in the opposite order. A, 4. What did I forget? Oh, why did I put A for the number of players? Okay, it's hard to focus when your teeth feel like they're falling out. B, 4, 6.7, we'll go blah, blah, 5.2, blah, blah, 1.2, like 0.2 for some reason, and then A, 5.0. All right, so now we have the list of board games entered in a random order, sorted from the best rated, so the highest number, down to the lowest. So we have 6.7, 5.2, yada, yada, yada. So with this code, in this video and the last video, you should be able to do the conferences assignment now, and I think you have a week, so that should be good. Good enough. If you have any questions, make sure you post them in the chat. I mean, I'm about to leave, so make sure you email me, I guess. Now what did I say I was going to do here? Oh, send you guys the code, right. That's not the right button. Oh. This is different. Change this. I'll have to try that out. All right. Wait, no, we don't want to invite you to edit it. We want to just give you the link to it. So that must have changed. Oh well. Let's put this in here. Let's make it an announcement. C# chapter 9 demo 2 for the homework. All right. Anyway, I'm gonna go scream about my teeth, and you guys have a good day, and I'll see you next week. Email me if you need anything. Have a good day and weekend. See you on Thursday.